So today we'll be learning how to represent linear functions in 4 very easy ways. And the first way is going to be a story. Then we're going to move into equations like y equals mx plus b, where m is your slope and b is your y-intercept. Then we're going to go from equations to tables, like an input to output, where your x is your input and your y is your output. And then from tables, we can plot the points from the table and create a graph with your x-axis on the bottom, or your x's on the bottom, and your y's on the y-axis. So I have this little diagram here that shows we're going from story to equation, equation to table, table to graph. You can also go from graph to table, graph, table to equation, and equation to a story. All right, example 1. Write the story in 3 other ways. Our story is Joe rents a boat for $2 per hour plus a flat fee of $20. So a flat fee means that he has to pay $20 no matter how many hours he rents the boat for. So if he rents the boat for 0 hours, he still has to pay that $20 flat fee. Or even if he rents the boat for 5 hours, he still has to pay that $20 flat fee. All right, so we have C is my cost, and H is my hours. So my equation, C equals 2 times the number of hours plus my flat fee of $20. So that would be my equation. In the table, we have for 0 hours, I just substitute that in. 2 times 0 plus 20 gives us $20. For 1 hour, 2 times 1 hour plus 20 gives us $22. For 2 hours he rents the boat for. We plug it in. 2 times 2 is 4 hours. 2 times 2 is 4. 4 plus 20 is $24. That's the total cost for 2 hours. If you rents the boat for 3 hours, plug it in. 2 times 3 is 6. 6 plus 20, the total cost would be 26. So we can take these and write them as ordered pairs. 0, 20, 1, 22, 2, 24, and 3, 26, and create a graph. So that's what I've done. My y-intercept is 20. That's my b. And my slope is my rise over run, and it's also the 2. My slope is 2. And we've just plotted the points. All right, example number 2. Write the story in 3 other ways. The story is the temperature drops 5 degrees per hour after starting at 72 degrees Fahrenheit. So temperature is my T, and hours is my H. So the temperature equals negative 5 degrees times the hour plus 72 degrees. Now it's a negative slope because the temperature is dropping. And if the temperature was going up, it would have been a positive slope. So after 0 hours, the temperature is going to be negative 72 degrees. After 1 hour, we have to do 72 minus 5, or negative 5 times 1 plus 72. It's going to be 67 degrees. Or this is actually positive 72. And then after 2 hours, negative 5 times 2 is negative 10, plus 72 gives us 62 degrees. And after 3 hours, negative 5 times 15 is negative 15, plus 72 gives us a temperature of 57 degrees. So we can make predictions in the future, like weathermen, based on the hours. So if we were to say after 10 hours, we can make a prediction on what the temperature would be. So to take this to the graph, we would say that after 0 hours, the temperature is 72 degrees. After 1 hour, the temperature is 67 degrees. After 2 hours, the temperature is 62 degrees. Move this one over just a little bit. Move this one over a little bit more. Let's see, 2 and 62. And after 3 hours, the temperature is 57 degrees. What we can do is we can draw a line through all of these to make predictions. That's a little rough, but there we go. Okay, so that would be my graph that represents the temperature over time. Temperature as time goes on. All right, last one. So here we have a graph, and our independent variable is hours, and our dependent variable is distance. So we have distance over time. So we can take this graph, and we know that the y-intercept, b, equals 40, and the slope, m, equals, well, we can figure this out. Well, we can do rise over run, but it's a little unclear. What we can do is we can sort of take these points and plot them on the graph, or put them on the table. So after 0 hours, the distance is 40. After 1 hour, the distance is about 50. After 2 hours, the distance is 60 centimeters. And after 3 hours, the distance is 70. If we notice in the table, we're going up by 10 each time, so we would say that the slope of this line is 10. So we now have the slope, and we have the y-intercept, so we can go ahead and write our equation. So we'd say y equals 10x plus 4. And that would be our equation. And then we can go ahead and write some sort of story. So you can write any sort of story you want. So my story is going to involve a slug. Oh, 40. Yes, excuse me. 40 would be my y-intercept. So I'm going to write a story about a slug, and I'll say a slug starts moving 40 centimeters away from a motion detector. It moves away at a constant rate of 10 centimeters per hour. So that would be my story.